Let's begin with our NSEM paper. So, our first question is discuss attribute by attribute problems that may have found into following database. Let us discuss attributes by attributes, some of the problems that have found their way into the dataset. The customer ID variable seems to be fine. We can see the customer ID 1001, 1002, 1003, 4, 5. It's all fine. Now, attributes of zip. Here we are expecting all the customers in the database to have the usual 5 numeral US zip code. The customer 1002 is okay. Now, customer 1002 has zip code J25S7K7. It is unusual value. It is like it's an error. Not all countries use the same zip code format, so it's not valid. Now we will check for 1003. It's okay. 1004. Actually, this is the zip code of, so probably represents real data from a real customer. 1003 is okay. For customer 1004, we are unaware of any countries that have four-digit zip codes, such as the 6269 indicated here. So this must be an error, right? Probably not. Zip codes for the New England states begin with the numeral 0 unless the zip code field is defined to be character and not numeric. The software will probably chop off the leading 0, which is apparently what happened here. The zip code is probably 06269, which refers to Stores, Connecticut. Connecticut. Gender attributes contain a missing value for 1003. We have gender for 1004 customer ID, 1002 customer ID, 1003 customer ID. But sorry, when we see the customer ID 1003, the gender is missing. Now we will check for income field. Income cannot be in minus, so this is wrong. And um, customer ID 1004's reported income of $40,000 lies beyond the field bounds for income and therefore must be an error. For customer 1005's income of $99,999, perhaps it may in fact be valid, but if all the other incomes are rounded to the nearest $5,000, why the precision with customer 1005? Now we will check for age field. Although all the customers have numerical value for ages, customer 1001's age of C probably reflects an earlier categorization of this man's age into an bin labeled C. Customer 1004's age of 0, perhaps there is a newborn male living in Stores, Connecticut, who has made a transaction of $1,000. More likely, the age of this person is probably missing and was coded as 0 to indicate this or some other anomalous condition. Example, refuse to provide the age information. Of course, keeping an age field in a database is a minefield in itself, since the passage of time will quickly make the field values obsolete and misleading. It is better to keep date type field in a database. Now, the marital status field seems fine. Married. The problem lies in the meaning behind these symbols. We all think we know what these symbols mean, but are sometimes surprised. For example, cold water in a restroom in Montreal, and turn on the faucet marked C, since the C stands for, which is French for hot. Thus, there is also the problem of ambiguity. In above table, does the S for customer 1003 and 1004 stand for single or separated? Transaction. The transaction amount field seems satisfactory as long as we are confident that we know what unit of measure is being used and that all records are transacted in this unit. Now for question 2, apply data wrangling process in following database. Name, we can see Jagdish Singh, Jain Tilak, Gupta Binod, Arun Fakira, Jackie Agrawal. Phone number, birth date, state. In data wrangling process, all names are now formatted the same way, first name, then last name. And phone numbers are also formatted in the same way where area code ABC and this. Dates are formatted numerically. First we will write year, then month, then date. States are not abbreviated. The entry for Jackie Agrawal did not have fully formatted data. The area code on the phone number is missing and the birth date had no year. So it was discarded from the dataset. Now that the resulting dataset is clean, readable for deployment or evaluation, Jagdish Singh, phone number, date, and state. We can see now this is resolved dataset. Question number 3. Consider following database. Apply any three methods for finding out missing values. ID A1, A2, A3, with user defined constants, with mean or mode, with random draws from the values distribution of the variables. Now first ID is 14.000, replacing missing fields with user defined constants. Like here, A2 value was missing for ID number 2, so we have replaced it with 0, or we have filled. Now for ID 4, A4 value was missing, so we just wrote missing. Replacing missing fields with mean or modes, we will take mean of all the values and then we will put the mean here. And same goes for A4. Now, with random draws from the distribution of the variable, we just randomly put the values here. Now, fourth question is classify bank loan applications by assigning applications to one of the three risk values. Use entropy and information gain approach. What is given? We can see first. Let us see the table. Who owns home? Who are married? Their gender? They are employed or not? Credit rating and risk class. Here we can see number of classes are equal to 10. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So number of examples S is equal to 10. Number of classes A, B, C. So number of classes are 3. Frequency of class, how many times A is repeated? Let us count. A 1, 2, and 3. So A equal to 3. Now B 1, 2, 3. B equal to 3. C 1, 2, 3, 4. So C equal to 4. Overall information in the given data due to uncertainty of outcome regarding the risk class each person belongs to is given by I equal to, it's a formula. I equal to minus 3 by 10 log 3 by 10 minus 3 by 10 log 3 by 10 minus 4 by 10 log 4 by 10. I is equal to 1.5, 1.57. Let us consider using each attribute in turn as a candidate to split the example. Attribute 1 owns home, attribute 2 married, attribute 3 gender. For value y, there are 5 applicants who own home. There are in classes A equal to 1, B equal to 2, C equal to 2. So value is equal to n. There are 5 applicants who do not who owns home. They are in classes A equal to 2, B equal to 1, C equal to 2. Now we will put the formula here and we will calculate the total information, and this is equal to 1.52. Same we will same this procedure will be repeated for married, attribute gender, for employed attribute, and for credit rating. Now we can reduce the data by removing the attribute gender and removing the class B, since all class B have gender equal to male. So we have removed it. So the information on this data of two classes due to uncertainty of outcome regarding the class each person belong is given by this formula. So let us consider each attribute in turn as a candidate to split the sample. There is no need to consider other attribute now because no other attribute can be better. The split attribute merit will be used to split attribute. Here is the answer. Let us begin with question number 5. Let us come to question number 5. Compare the attributes for classification of bank loan applications by assigning applications to one of the three risk classes. Attributes comparison based on information gain, not necessarily always fair. This approach favors those attributes that have larger number of values. If there was an attribute that had a large number of values such that each value resulted in only one element of the data set, then that attribute will be selected, although might not be optimum split attribute in the data. It leads to wide tree with depth 1, quite inaccurate for unseen data. Thank you.